So anyway, I'm going to just give you a little background on one of the experiments that I did. I had a study that took place over 3 years in a field situation, and then I also did a greenhouse study. So one of the things you're going to be looking at here with the microscope is the results of one of the studies that or the tests I did for my greenhouse study. But I want to talk to you about my field study because that's the background for my greenhouse study. So in a long sort of process, we'll get to what's under the microscope here in a minute. So my PhD focused on organic farming and the calcareous soil that we have to deal with in Wyoming. You guys know what calcareous soil is? High pH, lots of calcium, that kind of thing. Lots of calcium carbonate content in the soil, and that's typical for our region, the whole Rocky Mountain West in a way, Intermountain West. And so when you have a lot of calcium in your soil, it's beneficial in terms of it's a nutrient that plants need, but when you have a lot of it, it also sticks to phosphorus and binds it, and then your plants can't get at it. So we have phosphorus in our soils, but accessing what's there is difficult and can be very limiting. So a lot of farmers will add conventional fertilizer, triple superphosphate, whatever, MAP, monoammonium phosphate. But when you are an organic farmer, you can't add those materials, so you have to seek alternatives. And so my research with this field study was to add different amendments to the soil that are allowed under the organic rules and see how they improved, hopefully, or whatever their dynamic effect was on soil phosphorus, the labile or the accessible phosphorus pools that plants can get at. And so we use things like humic acid, which is this stuff, compost tea, bone meal, and then also rock phosphate here, so you guys can look at those if you'd like. And you can see that some of them are liquid, some of them are granular. And I did materials alone, so some plots were just bone meal or compost tea, whereas other plots had a combination of a liquid and a dry material. And we wanted to see if there's any synergism. And so I did that over a half pivot down in the Lingle Research Station area, which is by Torrington. It's in Lingle, which is about 10 miles west of Torrington. And so that was where my field study was. And we did that over a 3-year crop rotation of alfalfa, corn, and then dry beans. And I would sample the soil and test it. And I wanted to see if adding these improved what we would call soil test P, right? Your soil test phosphorus. So when you take a soil sample, you send it to the lab, you get back your results for how much nitrogen you might need to add, what your soil test, your phosphorus levels are, that sort of thing. And so based on what our soil phosphorus tests were coming out as, we wanted to see if these were improving that or hindering it or making any difference at all whatsoever. Because these are materials that are marketed to organic farmers. And there's research that says, you know, some of this stuff's great, and then the other research says, well, it's terrible, it doesn't do anything. So it's really conflicting, and it's hard as a farmer to make a decision. Yeah?
I was going to ask you, so the bone meal doesn't have any phosphorus in it at all?
It does.
It does.
Bone is a very rich source of phosphorus, but what else is in bone?
Calcium, I thought.
Yeah, calcium.
So it keeps it bound up?
It could, but it also, because it's steamed and broken down and it has a small surface area because it's a pelletized product, it could potentially be a very good substance for like microbes and other things to act upon and break it apart. Same with this rock phosphorus. So the rock phosphate is a mined material. This is basically steam-treated, ground-up bone from slaughter facilities. They usually get rid of the proteinaceous compound. If you had meat and bone meal, you would have a lot more protein associated with it because that meat and other tissues would be there. Okay. So this is pretty much just clean-up, washed-up bone that's been cooked. Humic acid is a pretty interesting product. It looks like oil, and it's a derivative of coal, leonardite specifically, and it looks oily and gunky, and we're gonna just not open the lid on that. And you can get it as a pelletized product or a liquid. And then this is compost tea. Now granted, it's a little old. I wouldn't recommend using this, but do you guys know how they make compost tea?
Compost tea?
Compost tea.
Rinse filter water through it?
Basically, that's what it is. Like a giant bag of compost, that's your tea. You steep it with water, and then you get the extract, okay? And it can have other things added to it, other nutrients, other microbes, molasses, I mean, galore things could be added to it. So, highly variable. You know, heavy metals can be more of an issue with this stuff, actually, because it is a mined material, and you just never know what you're gonna find. It's not purified and cleaned up in a lot of different ways. So those are the things that I added. And what we did find in our field study was really adding anything was good in terms of yield. If you didn't add things in our control plot where there was nothing added, we didn't see good yield returns, at least in our alfalfa. So that whole organic by neglect, you know, you can't be just an organic farmer by like not doing anything to your fields. You have to actively manage that soil fertility, which is required under the NOP regulations anyway, the National Organic Program. So we did find that, you know, you can add these different things and you'll see a benefit in your yield potentially, and also in your soil phosphorus. We did see that humic acid, sometimes combined with either rock phosphate or the compost tea and rock phosphate, did a pretty good job of enhancing soil test phosphorus levels, so they pushed it up a little. Now, was it outstanding? No. It was not as good as manure. And what our goal here kind of was to see, can we use these in lieu of manure? Because getting a lot of manure in Wyoming on your farms it's difficult. It's spendy. There just isn't a lot in terms of our area where we have lots of feeding operations, CAFOs, feedlots, to get massive quantities. So we need to find other things that might be useful. So there was some potential that we saw with like the rock phosphate and some of these other liquids. So then,
You want something useful, but you also want something that's cheap to access, right?
Economical. Yes,
yeah.
Yes, absolutely.
Not cheap, but economical.
Right, and so what we did was in our field study, we applied these at the manufacturer's recommended rate, all right? And so, they varied a little bit. This one is the spendiest. It costs about $1.90 a pound, and you'd use around anywhere from 400 to about 1,500 pounds per acre, depending on your application rate. So this is the spendiest by far. This stuff was this was like 27 cents per pound, and this would be anywhere from 300 to 500 pounds per acre. And these would vary by gallon per acre, anywhere from 2 to 12 or 15.
2 to 12 gallons per acre?
2 to 12 gallons per acre, yeah.
Gallons per acre.
So it could vary, and this is typically a foliar applied substance. So you apply it to the plant, okay, this more to the soil. So I did that and found there's some value. So what we did in our greenhouse study was we wanted to take these same materials, use that same soil, and grow alfalfa in some pots. And so we did that. Well, I did that. And what I found was that we didn't see some of the benefits that we saw in the field study. In our greenhouse, the yield really didn't differ between any of these particular substances. So again, you could apply that or that, and you'd still have a similar yield. One of the things that I'm going to show you under the microscope is I was looking to see if there was mycorrhizal association. So any sort of fungal association, sort of that microbial or fungal net that you can see in the soil, because it helps to forage for nutrients in the soil and it helps plant roots. And so I was looking to see that. What you'll see under here is basically my plant roots, which I harvested. So from one plant, this is how many roots I got from my old greenhouse pot of one alfalfa plant per pot. So there's a lot here, lots of roots. Seems like it'd be a good healthy plant, potentially. The other one on the other end of the spectrum, this poor little guy, pretty pathetic root biomass.
Same age and everything?
They were all grown at the same time, yep, exactly. And then here's kind of one that's in the middle of the road. So I had 144 pots, so I had 144 things of roots and 144 things of the above ground biomass. And I took those and I took a portion of the roots and put them in it's a biopsy cassette that hospitals and labs will use for human tissue, but you can put the roots in here, and I washed them in some scary chemicals and stained them a scary blue with some other scary chemicals, and so we're not going to open or touch anything here, just an FYI. But what I did do was I put the roots out on a grid of a petri dish, and basically what I wanted to do was scramble the roots out on this dish and then count along every grid line. Wherever there was a root that would intersect, I would note how many there were. And then I would also count how many of these little blue dots, which is basically this sort of mycorrhizal association or this fungal association, that I could find on here. Now my roots don't look exactly like these because these are nice and, in a manual it's either white or blue. You'll see my roots are pretty blue still, but you can see in some places where there's actually some nodules that have formed. And if you look through here, in this particular field of vision, and you can adjust the ocular pieces to however far apart your own eyeballs are, but you can adjust these, and then you'll see along the red grid line that I have running on the petri dish, you'll see two big sort of blue bulbs. Those are the nodules, and those are really a Rhizobium, which is a bacteria. But having those in there is also good because they help with nitrogen fixation. You guys know about nitrogen fixation in legumes, basically, so you want to have those, and alfalfa, of course, is a legume. So I would count all those kind of things up, and wherever I would see also some other places, and if you look in the root, I think in this one, you can sort of see on one of the root stalks that comes up between these two bulbs, a dark blue circle. Okay, you'll see a little dark blue circle in that root. That's actually some sort of a mycorrhizal association. So I would count all those, I would scramble up the dish and count it again, I would scramble up the dish, I would count it again, and I would count every grid line up and down, every grid line left and right. So I did it a lot for every plant that I had. And then I determined what the percent mycorrhizal colonization was, how much the part of the whole, so how many roots I had intersect and how many were actually mycorrhiza. And I didn't see a whole lot of differences, although I will tell you that I know compost tea seemed to elicit a better colonization effect on the plants to some extent. But in general, nobody was a terrible performer and no one was the absolute outstanding best. I had a lot of variability. So, you know, from that field study into the greenhouse study, what can I say? Ultimately, you know, adding something to your soil to help boost phosphorus is going to be really good. From our field study, one thing we did find was that bone meal, if you really ramped up the rate, because in our greenhouse study we took these substances and added them at a 0 level, so we didn't basically add anything, and then we started adding different rates and went all the way up the scale to include the rates that we used in the field study to well and above and beyond those recommended rates to see if, you know, is there value in applying them even at higher rates, but you know, the cost is going to increase, right? So we wanted to look and see if that material at a high rate would benefit you. And in terms of mycorrhizal colonization, didn't see a whole lot. It didn't seem to affect our nutrient return or affect our yield. I did notice that it affected soil test phosphorus levels, so adding a lot of bone meal in particular, and even rock phosphate to some extent, boosted that soil test phosphorus, which makes sense. These materials supply a relatively large quantity of phosphorus relative to these guys, which really don't supply much, if any, okay? So they're more fertilizers. You're going to expect to see some of that. But adding them is beneficial. The problem with bone meal, as we talked about already, has calcium, has phosphorus. It boosted phosphorus levels in our soil. That's a good thing. But the cost, and I did some calculations. So at the very high rates, say 5,500 pounds per acre, it's going to cost almost $10,000 per acre. Per acre. And then if you were to base your alfalfa yields off of our average Wyoming yields, about 3.5 tons per acre, you'd need your soil to sell, or your hay to sell for $3,000 per ton. I don't know if anybody's willing to pay that much. I mean, it has to be like gold-plated alfalfa. It's got to be some pretty fantastic hay. So that's really unfeasible. It's just not possible. Plus, my other issue with bone meal is even though it benefits soil phosphorus in the short term, you're adding more calcium. And I don't think that's going to benefit you in the long run either. So, you know, these things have a value. I think that this probably is not going to be valuable in our typical Wyoming soils. There could be some potential benefit for here, here, or here. So economically speaking, you could choose any of these kind of products and you would probably see a benefit. It may be in a longer term. This is more of a slow release material. This might kickstart your plants a little bit, give you some more soil microbes. This might feed your soil microbes a little bit. But you need to keep actively managing that soil fertility and probably stay away from the bone meal at this point. And they vary in cost. So that comes down to your own management decision and what you want to invest and get back in terms of your yield and things. So a lot of projections and, you know, no absolute black and white answers here. But that's research, right?
Yeah.
Just leads to more questions. Yes?
In consecutive years, is it cumulative? Of it, or?
You know, I think what I've seen with this particular product and even this one is you could see an increase. You're building your total soil phosphorus levels here, and that sort of has a trickle down effect. I think it sort of almost, it doesn't overwhelm the system, but it gives more phosphorus that's in a recalcitrant or less available form. Pumping it into the system makes the chance for having more available phosphorus better, because as the plants deplete that available phosphorus pool, you have more total phosphorus to kind of refill it. So it takes time, though. It's again a long-term investment.
But you need less each year.
You know,
Possibly need
yeah,
less
I mean,
of that each
eventually.
year?
Yeah, eventually. They do recommend this to be, you know, for the first 5 years, I think, under the Ida Grow website, they said, you know, up to 5 years, you can add 300 to 500 pounds per acre of rock phosphate. And then you're kind of reaching a point where you want to see how it kind of depletes and how it manages itself as you deplete it with your crops and your other management systems. Are you adding organic matter? You know, that's going to help sustain that a little bit, and it can even keep that sort of system closed where you're losing some phosphorus but you're gaining it back, and it keeps it cycling nicely along. Eventually you would have to come to a point where it probably is depleted and you need to kick that back up.
But are you building your calcium up so high?
Only with this stuff. I mean, there's calcium in here. There's all sorts of stuff in here. There's even heavy metals in there. So there's a risk with some of those things too.
Renee,
Okay, yeah.
Can I ask you, why didn't you just use regular compost? I mean, it seems like you have to go through another filtering step. Why not just go
Cost.
compost?
it's not always accessible where our organic farmers are. You know, you can order from Colorado. It's spendy to get it delivered. I mean, this stuff is not cheap either because it's very heavy. But we've seen more farmers using other things that they can make on farm, and you can make your own compost tea on farm.
But why not just use compost?
Well, again, it's
So
sort of
why-
like the situation with the manure. You don't have a lot of access to it, so to get it to where you need it on your fields, you need to truck it in. It's very spendy.
Okay.
So that's why we just basically eliminated that
And
one
the other
from the
thing about
mix.
compost, doesn't compost vary depending on what you
Oh,
put in your
absolutely.
pile? I mean,
So does
it's
this
also-
stuff.
Yeah,
This,
so
I mean,
how do you know what you're getting? How can you
exactly.
quality control check and be consistent and get a
you
reproducible?
could make your own. We
Yeah,
use the
there you
same
go.
product every time, and it was a
Okay.
prepared product, so we weren't brewing it or anything like that to
Okay.
hopefully eliminate some of that variability. But it's compost. It's going to vary, just like
Okay.
manure is from
Yeah.
year to year. You know, it depends on how long it's aged, what
And what
animals it
what
came
animal?
from.
Yeah, exactly.
A lot of variability, so there's always going to be that.
Can you make a bone meal tea? And just get
If you needed an alternative to
Save your
something
animals when they die.
for calcium, I don't know. I'm pretty sure it would be disgusting. Yeah. So have a steak
I can
instead.
guarantee it.
So, do we need to rotate again?
We're about 5 minutes.
Okay,
so-
all right. Oh, good. Okay, because last time I talked too long. Yeah.
Leonardite is essentially a carbonaceous shale.
It's more of it's like a precursor to something that might become coal. It's decayed plant matter and rotten animal matter. You can't really tell what it is anymore. You can find something similar to it if you go into a forest and you see rotten leaves and sticks that have decayed so much that it forms this dark brown kind of black gunk under the litter.
But
That's
it's-
essentially what it comes from.
Leonardite is mined.
Yes, it is mined. Mhm.
So how is that produced?
They will extract, just similar to this, you take the raw, harder
Water-
material,
water leach.
they'll run an alkaline extractant through here. The pH of this stuff is around 11. So it's an alkaline extractant. That's what makes it the humic acid portion. But it's basically all the good stuff of the decayed plants and animal material. That's already been kind of consumed. This stuff takes a long time to break down. It's got a lot of carbon in it. Hydrogen, it's a recalcitrant, slow release form of carbon and other nutrients. And they all pretty much are, other than this one, which, research has shown that's great for suppressing plant disease. So if, the value for using this didn't maybe directly benefit our soil, but if we had robust plant growth, they could forage further in the soil to procure nutrients, and then of course that would benefit their yield eventually. So, there's benefits for each, there's drawbacks for each, certainly.
Point is to do something though, I guess, huh?
Yes, so,
Be active.
Yeah.
I was gonna, can you add too much phosphorus? I mean, how do-
You can in situations where you don't have it doesn't feel like an arid climate or semi-arid here this week, but in places where you have more of a semi-arid situation like we do, runoff typically is not an issue. Now with nitrogen it can be because it leaches through the soil. Phosphorus is very immobile. It sticks around, and the only real problem would be if you have things like tile drains or massive runoff of your soils into rivers and stream beds. That would be a problem. But typically that's not an issue here unless you fertilize and then it floods. That can be a contaminant issue.
Renee, what about mixing those?
Did see some benefits with this and the compost tea, and either also the humic acid with the rock phosphate. So there are some benefits of that synergy. This might have made the microbes happier in a way, so that they're cycling nutrients more effectively. And there's a lot of surface area when you have a pelletized product, so they can access stuff on these pellets, even here too. Whereas if you had big chunks, it would take a lot longer. So surface area, I think, plays a big role in that. And there is some research, and I think this may be one of the factors that we saw an effect or a benefit with these two, the humic acid and the rock phosphate. You can get humic acid to bind to some of the phosphorus that's on these rock phosphate pellets, and it can form a complex, a humic phosphorus complex that plants can access, microbes can access, and also it can interfere with calcium binding phosphorus. So if you get like this calcium stuck to humic acid, then the phosphorus is available and the plants can take it up. So that could be a benefit too.
If it's available, is there a large market for organic alfalfa?
Oh, absolutely. Yes, organic dairies. A lot of our producers sell to Colorado, California even. Yeah, the organic dairies are the big consumer of organic alfalfa. But even organic corn, organic beans, there is a market. And the market is continuing to grow, even with the economic recession. They hit the single-digit growth point, but it's back up again into the double digits. And as far as I'm aware, the Ag Marketing Service says there's a projected growth back into the mid-teens, which is where it was back in the 90s when it sort of took off.
The tough part with the organic alfalfa, at least, for us up here, is we have a hard time competing with Colorado. Colorado has the closest organic dairies that I know of.
Yeah, Horizon.
And
White
the
Wave.
tough part is we're about 2 to 3 weeks behind in our hay production up here than Colorado is. So Fort Collins will already have their organic certified fields cut, baled, into the dairies before we even cut. And so that's one difficulty of us. And then of course with the trucking.
Right, there's always that shipping cost.
So our market here for organic produce of like a hay or something, it is small, but there is the potential to grow.
And we have some farmers down around Torrington who grow their own organic feedstocks because that's what they feed their organic beef cattle or their own organic dairy cattle. We do have some dairy farmers down around Torrington, which is, I wasn't really aware of that. I knew that, Star Valley was always the dairy place, but there's some around Lingle, Torrington area, and they're producing organic milk. They've got the truck that comes up, gets their milk, and they produce their own organic alfalfa to feed their dairy cows.
But
And the
there-
hay market for horses too. I think sometimes that's a good alternative because, and in Colorado again, typically, there's a good market for high quality organic alfalfa hay for the horse market.
Or even California
Absolutely.
for the horse.
Yep.
Talking
So-
to California.
They'll pay for it.
Well, if you've listened the last 2 years, California's been in a drought,
Right.
and so they're
They
struggling
need
for
it.
hay production. But on top of that, California cannot produce enough hay for their own horses, basically, if you want to look at it that way. So
And
they-
horses are big bucks.
and they have the money to pay
Mm-hmm.
for our production, so.
Is
yeah,
there-
It's very unique.
Sorry. Was there any flaws on combining these? Like,
At really, really high rates, when I used this one with this one in my greenhouse study, we did see a decline in some of that soil phosphorus, and I wondered if perhaps there was so much of this that it started to sort of coat the pellets and make them almost inaccessible. That would be my hypothesis, anyway. You can overwhelm it and mix too much in there, and then the bugs have to work their way through this before they can get to the gooey center of the fertilizer goodies, as it were.
I'll stop.